Hey, look at that. We're on the last three problems. Now it says that the per unit cost in dollars of producing n items is given by C of n is equal to 0.125n squared minus 195n plus 77,325. It wants us to find the minimum per unit cost that should be produced and the actual number of items that should be produced to obtain this minimum. So I just need to find the vertex. I'm going to graph it, and I'm going to find the vertex. So again, I'm going to graph it. We're going to find the vertex. We're going to make sure we get the right x value and the right y value. Because again, the cost is the y value. The number of items is the x value. So if we go to Desmos, my best friend, y equals 0.125x squared minus 195x plus 77,325. Oh Lord, that's tall. That is very high. We're gonna have to zoom. There we go. Click on it. Click on that dot. Oh, thank goodness that was easier than I thought it would be. So again, I have the cost based off of a particular number of items. So if I produce 780 items, there's an input of 780 items, then my cost is minimized, and the cost of producing those items is only $1,275. So again, my vertex is straight up 780, comma 1,275, which means that 780 items minimizes cost at $1,275. Now, you very well may be able to use this to model the production costs of some things all on your own, depending on what you make and what you sell for whatever business it is you decide that you want to start up. Man, I love Desmos. The graph below shows the path of a football kick with height above the ground as a function of horizontal distance traveled. So x is horizontal distances and y is height. They're both being measured in yards. Determine, or the function is defining the path, and it's got h of x is equal to negative 0.05x squared plus x plus 1, where h is the height of the football in yards, and x is the horizontal distance it is thrown in yards. Kicked. It was kicked. Why does it say throw when it was kicked? So how many yards long is the kick? So, I mean, the kick starts at 0, and it hits the ground 21 yards away. Now I need to answer part A, which says, what's the maximum height that the football reaches? It looks like it reaches a maximum height of 6 yards, or 18 feet. From what height was the football kicked? That's asking for my starting value, my y-intercept. It was kicked from a height of 1 yard. Then it says, over what interval is the football falling towards the ground? Well, it reaches its maximum height, and then it falls down. So I'm falling from 10 yards away all the way to 21. So my interval of decrease is just from 10 to 21. Pretend that I press one of those big red buttons that says, that was easy. Last question, period. Suppose that you're tossing an apple up to a friend on a third floor balcony. Nice. After t seconds, the height of the apple in feet is given by the equation. H of t is equal to negative 16t squared plus 38.4t plus 0.96. Your friend catches the apple just as it reaches its highest point. So my friend catches the apple at the maximum, which means that I threw it at the perfect height. The perfect height. So let's graph it, and let's answer the questions. Alrighty, the equation again was negative 16 input squared plus 38.4 input plus 0.96. And I gotta zoom way in because my graph is messed up because I was zoomed way out for the 77 some thousand things being produced or whatever. But now that I'm here, I can see, hey, I start 0.96 feet above the ground. The apple goes up. My buddy catches it 24 feet above the ground, which is 1.2 seconds later. And then the apple would have hit the ground 2.425 seconds later had nobody caught it. So how long does it take the apple to reach my friend? That's going to be the x value of my vertex, which is 1.2 seconds. Now, at what height above the ground does your friend catch the apple? Since he caught it at the maximum, that maximum height was 24 feet. How high is the apple after 0.5 seconds? When they ask for a very specific input, you plug it into the table and give them a very specific output. So 0.5 seconds later. Forgot the point. My apple is 16.16 feet above the ground. Again, I got that by taking my equation, making it a table, and plugging in the very specific value that I asked for. Thank you for coming to my TED Talk.